Suscríbanse.
Bienvenidos a la última parte de mostrándole a Eric, que es graduado de física de la Universidad de California en Los Ángeles. Vamos a mostrarle la cuarta página del examen de la UNI de parte física 2025-2. Y bueno, aquí está Eric, por favor, haznos el honor.
Okay. A lot of circles. Was this supposed to be circle?
Again, I took this from the
Alright,
internet.
okay.
I don't know.
Where'd you bootleg this from? Alright. Well, let's...
Some other channel.
Yeah.
Some other channel.
Número 16. 16. Alright. Una bala de 100 gramos de masa que baja a 200 meters per second. I was gonna say meters per second. Golpea un bloque de madera. I know that's wood, right?
Mm-hmm.
Yeah, I know that one.
Mm-hmm.
Y la penetrará hasta una profundidad de 0.12 metros. Okay. Calculé aproximadamente.
Yes.
Aproximadamente.
Good job.
I'm just gonna say magnitude.
Magnitude.
That's all it is.
Uh-huh.
It's just magnitude. Okay. De la fuerza in 1,000. No, that's 10,000 years. Okay.
Mm-hmm.
Que ejerce la madera sobre la bala. Considere que la fuerza es constante y que para detener a la bala se usó toda su energía. Okay.
Thoughts?
Bala, just ball.
Bala is bullet.
Okay. A bullet has a mass. That would explain why it's moving so fast. And then it's shot into a block of wood.
Mm-hmm.
And it penetrates to a certain depth.
Yeah.
Calculate the magnitude of the force that ejerce de madera sobre
the force that the wood exerts on the bullets.
That's an interesting one. And what's the rest of this say?
Consider or assume that the force is constant.
Oh, okay.
Otherwise, you need calculus. Right?
Yeah. Otherwise, that's what I was wondering about. I was like, don't I need to do like delta t, delta n? Okay, so that's not that terrible then. It's a work problem. It's a work problem.
Mm-hmm. And probably momentum too. You think?
That's tough to say. I don't think so. I think it would be largely work. I don't think I would use momentum here.
Okay.
We'll circle back to it. I'm not sure.
Okay. Número 17, por favor, Eric.
Gotcha. Let's see. In el esquema mostrado, determine el valor de. Oh, dude. How do you say that in Spanish? How do you say that?
That's epsilon, right?
Yeah.
Epsilon.
You just say epsilon.
But
okay.
I think in physics, also in English, they just call that the electromotive force.
Yeah. Oh no, dude, I'm definitely skipping this one.
Oh, this is the one I'm curious about.
Okay, we can talk about it.
Yeah.
Okay, so electromotive force de la fuente in volts para que la intensidad del campo eléctrico en el condensador plano C, and then they give a value for the electric field strength. Considere que los valores de la resistencias son R is equal to R2. Okay, all right, they're all the same. Got it. Y la distancia entre las plazas de condensador es 5.0 millimeters. Got it. What the hell is going on in this problem? What is happening?
This is so interesting. The diagram looks so interesting. That's why
What am I supposed to do? Okay, first of all, can you help me understand? Like, I read the words. I don't understand.
Okay, it says in the given diagram, you want to find the electromotive force of the source, I think.
Yeah, that's like a power source.
Yeah, in volts, so that the intensity of the electric field in the plate on the plates.
Okay, so probably the capacitor.
Is E equals that number.
Okay.
Consider that the values of the resistances are
the same.
Yeah,
they're all equal.
And you know also the distance between
the plates.
Yeah.
What the hell? What is this problem? I think this is probably like I would call this what would I say? This is a I can't think of the word, but like this looks like it's both Kirchhoff's laws as well as calculating like capacitance and like voltage from capacitance and whatnot. So it's like it's canvassing for multiple parts of physics to like try and.
It sounds like a long problem.
Yeah,
like for an exam like this.
Yeah.
I think you have only 3 hours.
So I'm guessing much like something like the AP test here, that there is some sort of trick that lets you condense this and do this much quicker. Particularly the fact that all of the resistances are the same. I bet you there's some conclusion you can jump to from that makes this a lot simpler. I don't know what that is. And I don't understand. What is going on? What does this box do?
Yeah.
What is going on?
Looks like a lot is going on there. But, okay, we can circle back to this.
Oh, wait, I'm never looking at that.
Then let's completely skip this one and move on to número 18.
I'm as confused as you are.
Okay, número 18.
Okay, 18. Oh no. Oh no, look at all these words. And no picture. There's no picture.
Ooh, no picture.
Un móvil parte de reposo de se mueve en una trayectoria que describe una circunferencia de radio R. Still can't do R. Try. Cuyo módulo de la componente tangencial. Oh yeah, legit. De su aceleración, que es denotado por A. Is that? Oh, it's just okay. Es constante. Calcule al cabo de qué tiempo es módulo de la aceleración centrípeta será el doble del módulo de la aceleración tangencial. Considere que todas las cantidades son medidas en el sistema internacional. That was the hardest question to read.
Yeah.
So far. Oh man, I'm sweating.
It is a lot.
What does it mean? What does it all mean?
Yeah, okay, let's so you have a car that is moving from rest.
Okay.
In a trajectory that describes a circumference of radius big R.
Gotcha.
Whose module of the tangential component of the acceleration is denoted by A. That's a lot of stuff there.
Okay, say that again.
The magnitude, right?
The magnitude.
They said modulo, didn't I?
Yeah, is that what that square is?
Modulus is the right word for magnitude. What I meant to say is magnitude of, because it's a...
Got it. I was about to say, do you want the modulus? Like, what the fuck are you talking about?
Yeah, it's the...
Okay, so it's magnitude of the component, the tangential component. Tangential to the circle?
Yeah, to the trajectory, which is a circle.
Oh.
And then the question is how long it takes for the magnitude of the centripetal acceleration to be twice the magnitude of the
Tangential acceleration?
yes. It is.
At the very least, you didn't mention any banked curves.
Oh,
There's no banked curves, right?
no.
Oh, thank God. All right. So there's at least no banked curves. This is already like a huge headache of a problem. But if there were banked curves, I would lose my fucking mind. Like I would be so upset. There's no banked curves. I don't think we're gonna come back to this one.
All right, fair
I
enough.
don't think we're coming back to this one. There's two that I'm vetoing right off the bat. 17, 18.
Mm-hmm.
Oh, dude, no.
Yeah,
There's
this
no
last
way.
page is.
There's no way.
This last page is kind of brutal, huh?
This is really brutal. 16, 16, is reasonable. That's a reasonable problem. 17, I think, like, once again, there's probably a trick that I'm not thinking about. And then 18 is just like, it's just hardcore.
It's like, what's your problem, right?
Yeah, dude.
19, por favor.
Gotcha. At least it's short. El campo magnético máximo de una onda electromagnética es 40. It's always numbers. 40 microteslas. Microteslas. Calculé aproximadamente. Every time, dude. That word is littered all over.
We need a compilation of you saying that word, yeah.
La densidad de energía promedio de la onda electromagnética. I know what that word means.
Yeah.
La permeabilidad magnética en el vacío es, I don't know, some number. Okay, they gave me permeability of the magnetic field in a vacuum.
Mm-hmm.
I am afraid.
Okay.
What else is happening?
Yeah, you were given that the maximum magnetic field
Okay.
of an electromagnetic wave is 40 microtesla, and you want to calculate roughly, approximately,
The energy
density. Yeah, the energy density, the average energy density of the electromagnetic wave.
Gross.
Yeah, it's like.
So this one is a formula.
Maybe it's a formula.
It's a formula
Just
based
a
one.
formula,
It's a
yeah.
formula based one. I don't have the formula in my head.
Okay, that's fair.
Offhand. Dude, I'm just gonna crumple up this page.
Yeah, page 4 has been brutal.
Alright, so número 20. Un manómetro de tubo en forma de U abierto en ambos extremos contiene incidentalmente agua, luego se vierte aceite cuya densidad es de... Don't tell me. 750 kilograms per meter cubed. Que no se mezcla con el agua. Oh, dude, there it is again.
He's back.
Calculé aproximadamente la altura de la columna de aceite en meters que se muestra en la figura. Si la altura de la columna de agua es 0.2 meters. Okay. This page is hell on earth. This is terrible. Okay. Are you gonna force me? Are you gonna put a gun to my head and make me do one of these?
I would like you to pick one.
Okay.
And pick whichever you like. It doesn't have to be this one.
Right.
I think you like number 16.
Number 16 was like a reasonable question.
Okay.
It was reasonable.
Okay.
Number 20 or number 16? 17, 18, 19? 17, someone needs to show me how to do that.
Okay.
But 18 and 19 I could do with like some amount of prep work. Okay. So I have a bullet. Can I draw a bullet? Okay, it's not. It's not. It doesn't look like it. Now it looks like one. Oh, we got a block.
Yes, of wood.
There you go. You happy? You happy?
Very happy. Yes.
Now it looks more like a dick. Okay. It's 100 grams, so I gotta say mass 100 G. Okay. 10 grams. Okay. And it's traveling at a speed of 200 meters per second. Whoops. 200. Let's hit those meters per second. Alright. Okay, cool. So when it hits this block, it penetrates to a depth of 0.12 meters. Cool, sure. Calculate the force in tens of thousands of newtons. It's a little strange. Okay, sure.
It's gonna be pretty big, that's probably why.
Yeah, it's probably gonna be fine. So I think the first thing we would need to do is we need to know how much work needs to be done in order to bring this to a stop. So we would want to know work done in this case is going to be equal to the change in kinetic energy, right? So we want the bullet to come to a complete stop from this speed. So that is going to be whatever amount of work is done by this guy. So I'm just now realizing this is a pretty easy problem. Maybe the Spanish is throwing me off and it looks harder. Okay. So that's pretty easy. So we have like kinetic energy, final minus initial. Kinetic energy final is just 0 because it's at speed of 0. And then it'll be 1/2 mv squared, which we have those. We have those values. Do I plug those in now? 40,000 squared, 40,000 times. Oh, Jesus.
Or you can wait till the end, right? Work with variables.
You sound like Canales.
Well, that's the only one good tip she ever gave us.
You didn't like the be more stressed out tip?
No, I didn't appreciate it.
What were some other classes? Okay, so let's see. The other thing we have, like work done, is going to be force times distance. I'll just write that as a T instead of an R. So it's usually a little more complicated, right? Like it can be, it's usually a dot product, but like this is all a one-dimensional problem, so we don't really need to worry about that too much. So we have some work done. We don't know the force. We want to know the force. We have a distance. We have all of that work is being done within 0.12 meters. I will keep things in terms of variables for Diego's sake.
Thank you.
Let me just move this over. Wow, that was easy. Whoops. I thought this would be harder. There's still got to be a huge force, though.
Should be. The distance is small.
The distance is tiny.
Probably.
So let's see. I'm gonna try and do this in my head.
Really?
Until we get to this point. Then I'm screwed. I'm absolutely screwed. But
what's your units?
What is my units? It's got to be in newtons.
Yeah, with mass.
Oh! Thank you, Diego. Thank you. Oh, man, dude, I was so screwed. All right. So this would be 200 squared, which is 40,000, 4,000, 2,000. I don't think can you do this in your head?
Well, 0.12 is 12 over 100. Yeah. Just do it that way.
Oh, I'm just gonna. I give. I did enough.
We're just gonna use it.
Are you impressed yet? Okay, good. Ew.
What do you get?
So negative 16.9. Kelsey. Go.
2 points. Okay, that works for me.
Is that an answer? Oh, wait. It would have to be because they ask for it specifically in units of 10 to the 4th newtons.
Uh-huh.
Why?
That's a good
So let's
question.
see, 1, 2, 3, 4. Okay, so it's like 1.66 ... whatever. Is that an answer? It is. That is it. Woo,
Heck yeah. We did it. You did it.
I feel bad. That was way easier than I thought it was gonna be.
So do you want to pick another one?
Oh. Okay. Maybe I should hold my tongue because the rest of the problems here, except for number 20, are like battery acid. They're just terrible. They're terrible.
Yeah, that was mean, huh? That was mean. Yeah, esto es lo que piensa Eric de la última página del examen de la UNI. Ouch.
No more, please.
Yeah, so Eric, what are your thoughts about this test? This is the physics test, and on that same day, the students have to take 20 physics questions and 20 chemistry questions in 3 hours.
20.
Yes,
Okay.
this is a total of 20 questions.
This was a total of 20. Okay.
What are your thoughts?
I feel like, because I've done some help with like prepping students for AP tests. I feel like the AP test here has more just mean-spirited stuff where you're supposed to get stuff, where like they just throw stuff at you that you are supposed to get wrong. This seems a little more fair, but
Nice.
but still difficult. Just less of the like random bullshit that they put in questions to try and make you not pass. I think you said 20 questions physics, all multiple choice.
All of them, yep.
20 questions, same for chemistry,
Uh-huh.
in 3 hours. That's still a lot. That's still a lot. And some of these problems still feel like you have to know a trick on top of like just knowing all of your formulas and whatnot, which is hard. So you have to study your formulas. I don't think there were any that were like too obscure, right? Like they were all formulas that you reasonably should know, or that I should reasonably know if I, haven't been out of physics for like 10 years. I don't know. I think it's tough but fair.
Okay.
Is my opinion.
How would you rate the AP Physics here in the US, in difficulty versus this exam?
I think the AP test is on average harder, but it's different year to year. But some of that is like the sort of like what do you call it, like manufactured difficulty, like intentionally putting red herrings into a problem so that students can't tell which thing they're supposed to be looking at.
And you don't feel they do that here?
I didn't feel like that. I saw that here. Could be because of the fact that it's all in Spanish and like your translations are helping kind of weed through the extra bullshit. Did you feel like there was extra bullshit? Or
in some problems, yeah. Some problems I feel like they were, like you said, manufactured to just not get it right.
okay.
But I think that if you know all the formulas and
That's
just have to
yeah.
practice a ton
Right.
for this test, I guess.
I think the like biggest piece of advice I can give someone after looking through all of these is just like, make a cheat sheet of all your formulas and just make sure you have them memorized so that they're easy to recall because you're time pressured too. So that's the best piece of advice I have. And, just take it easy. It's just a test. It'll be fine.
Okay.
Right.
Muchas gracias a los nuevos suscriptores por su suscripción y gracias por ver este video donde mi amigo Eric, físico de la Universidad de California de Los Ángeles, probó los problemas de física de este examen de admisión. Si conocen otras formas de hacer estos problemas, díganme por favor en los comentarios. Y muchas gracias, dejen su like por favor y suscríbanse.
Suscríbanse.